how you do this. Find the area, and now done both. This one you have to find this one. Now you have to find, because I give you this one. Now I give you. I make it bigger. Now I give you this one, right? You don't need any Pythagoras theorem. So okay, you're supposed to find the area here. Everything okay? After you find the area, find what is the area. After finding the area, you find the parameter. Let's start with the area. Mm. How do you find the area? The first thing you do is now they actually show you this is a parallelogram. No, this is a parallel. These two are parallel. So I'm sure you can find this one, right? This is actually trapezium, isn't it? This is trapezium. So find the trapezium first. Yeah. After finding the trapezium, find the area of the circle. Then you add two together. Okay. Uh, area A plus area B. You get the total area. Can you do that? So let me write. Oops. Uh, do this again. Area of trapezium. Trapezium. Area half A plus B times height. Okay. What is A? Yeah, on top, right? Half. I'll take 16 plus what? What is B? Mandy? What is B? Mandy? 20. Yeah, correct. What is H? What's H? 14. Total? Half? 36, right? 36. 14. Total? Answer? So 36 times 7. 36 times 7. 252. If you're finding an area, it must be centimeter square. So find the area, I underline, because I need data, okay? I underline, So area done. So this is 252 cm square. Only a trapezium, but you need a semicircle, right? Okay, so I put it on the left. Area of semicircle. Half. Sorry. Yeah, half, right? Half divided by 2, isn't it? What is the area for circle? Andy, what's the area of circle? Square. Why did I? Why is it I divide by 2? What is the reason? Why is it I divide by 2? Semi, right? I already say semi, so you must divide by 2. Okay, equals to, slowly, do slowly. So you have, now pi, they ask you to take pi to be 3.142. So you don't go and press a calculator. You need this, okay? You need this. Don't use the calculator. Use this. Equal times 3.142. What is the 142 times? What is the radius? Diameter is 14. Radius is 7. So 7 square, 7 half, right? Times 7 square. So you have 3.142 times 2 times 49 divided by 2. 3.142 times sorry, 3.142 times 49 divided by 2. Yeah. 66.9. 76.9. All confirm? 76.9? Okay, 979. 76.979. Yeah, it's good that you have three decimal places. Yeah. Centimeter square. All confirm? Anyone? Okay. So now you need to total area, right? So the total I put below. Total area equals to, I add two together. 252 plus 76.979 equal. Answer. 252 plus, so you will have let me see, 8 2 3 3 2 8.979 cm squared. Is that correct? Confirm, please. Correct? Yeah. 328 lah, this chart. 328. Okay? Yeah. But they put the word correct to three significant figure, right? In the exam, they never give you how many places. Please don't use any significant figure. If there's a decimal point, use at least 3 decimal places, not 3 significant unless they tell you. Yeah. They didn't tell you, don't leave 3 significant figure, but 3 decimal places. If they don't tell you, if they tell you, then you have to leave it according to what they want. So this is the answer, right? Okay. Now, if you want to find the parameter, you must add this, right? This plus this, all you know, but the only thing you don't know is this one, right? So you must find the circumference of the semicircle. Once you find this, you can add 16, can add 14.6 plus 20, that's the answer. So you must find this. Here, only here, inside don't count, okay? Parameter, you don't count inside. You can only count outside. Outside, this one, and this one, yeah. You cannot add this. Perimeter is only outside. 1, 2, 3, 4. Yeah. Okay, so I'll use this is the half circumference, isn't it? Again, I divide by 2. So, uh, uh, circumference of half circle, so I put below. Circumference of half circle equals to half 2 pi r, right? So if I have the half, I cancel the 2 gone already, isn't it? So I have pi r equals to 3.142 times 7 only, isn't it? Yeah. 3.142 times 7, anybody? Or do half 3.1 times 7. 7 times 2, 14. 4 times 7, 28, 29. 1 times 7, 9, 7, 21. 21.994 cm. No square because circumference, right? Isn't it? Am I correct? Can you check? 21.99, 21.994. Correct, Okay, so we okay, you have this ready, right? So what do you do? For the circumference of the whole field, what do you do? You take this right center, isn't it? Plus what? 16, right? Plus 14.6 plus the you want to plus 20 also, right? Yeah. Can you give the answer, please? So parameter equals to I'll take 21.994 plus 16 plus 14.6 plus 20, right? Equals to, sorry, answer? 20 plus 2. 72.9. Answer? 994. Oh, 594. 594 cm with a square? No square, right? Perimeter, no square. So that's answer. Correct? Say correct, eh? Correct, eh? Is there any, decimal place that you did? Do you leave any decimal place? A decimal place. It's only 2.594. Do you leave any decimal place? Exactly. So no decimal places. So I leave it now. Yeah, exactly. Okay. Then later I finish. 72.594. All good? Anyone? It's okay for you. Good. Yeah. The working is here, of course. I I don't use this because they chunk everything together. They chunk everything together. So some of you might not understand what they're doing. They put everything together. Yeah. But if you can put everything together, that's fine. No? You can see it's shorter, right? But sometimes you look at it, do what they do. I put everything all together. Yeah. So I separate them bit by bit. Then you'll know what you're supposed to do. Okay? Right? Any question? All good? Move on now. Move on. Is there any more? One more. Clear this, please. Clear. Fine. Clear page. Okay. Okay. Let's look at diagram. Now, did they say this is a parallelogram? Did they say this is a parallelogram? Sure, did they say the parallelogram? Two arrow, right? One arrow, one so this is a parallelogram. So sometimes the exam they will show you this, they will tell you, they will show the arrow. So you have to be very careful. Look at the arrow, what it's saying. Arrow indicate you parallel, 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 parallel. So this is a parallelogram. If I ask you to find the area of the parallelogram, I'm sure you can find this on type, right? Yeah. But the thing is, this parallelogram has a hole here. So you must minus a hole, right? How do you find the hole? The hole is a circle. So you find the area of the parallelogram minus the area of the hole, you have answer, isn't it? Yeah. So that's what you want. Given that the hole is at the center of the circle, and the radius is 5. So from here to here, 5. 5, right? Given 5, right? Find the area of the shaded. The word shaded means yeah, minus the hole. Yeah. That's called shaded region. So you're supposed to find this. You're going to find this. Find the area of this. All you need to do is find the whole area first, then minus the area here. Okay, you will have the shaded region. Okay. So what do you want to do? Either one first. Do you want to find the circle area of the circle first, or do you want to find the area of the parallelogram first? I will find the area of parallelogram first. So one thing at a time. Okay. You see that because in the solution, they give you everything together. Notice everything seems very short, right? But you must know what they're doing. So I'll separate them. I will find the area of the parallelogram first. I will use this. Let's start. Area of parallelogram. Parallelogram, there's a formula, isn't it? Base times height, right? What is the base? Base times height. Base 18. Height 8. Straightforward, right? 18 times 8. 18 times 8. 8 times 8, 64. 1 times 8, 14. 144 cm square. Right? First one, I underline so that I know I have to use this data. Now I find the area of the circle. Area of circle. Pi r square, right? Pi r square. Did they tell you what is the radius of the circle? 5. Here, 5. So pi 3. Take 3.142. Cannot take any other thing except 3.142. Cannot. So you have equals to 3.142 times 5 squared. Someone give me answer, please. 78.15. 78.55. 5 cm square. I underline because I need it. Okay, total area. So the area of the shaded region is, I'll do it here. Area of the shaded region. Area of shaded region equals to 144 minus the circle, right? 78.55. Answer? 65.45. 45 cm what? Is that a square? Is the area, right? Just confirm 65.45. Okay, correct. They use three significant figure. Don't use significant figure. Use decimal places. Yeah. So this is the answer. Correct. Is it okay? Maintain? What time did you pick? You picked an exam. You took it. You get small. Yeah. Pass. Or so you just come later. Yeah. Oh, so good. No, I never go further. Yeah, you just stop there. Stop there. Oh. I'm not working. Oh. So you'll be sitting on the exam again, right? Will you distribute the same answer that is yeah. Hope you pass, huh? Hey, Mr. You got him, huh? You help him? Sometimes I oh, sorry, so I asked him if he cannot move on. Oh. Don't have the sound motivator. Some. But he's so stated, recently a bit. Yeah. Okay, all good? Yeah. Any question, anyone? Not difficult, straightforward. Yeah. The only thing you need to know is when you give a diagram, where is the height? Always know, identify the height. Yeah? The height, whether it's a parallelogram, whether it is a trapezium, if it's a triangle, where's the height again? You know, where is the height and is the height of the triangle and the height of the parallelogram are the same? Very likely the same. So these are the things that you need to know. Just apply formula you can answer. I'm going to show you this one. This one tama, this one. Okay. Yeah, conversion. Sekali ini. Okay. This one, let me show you, okay? Conversion of the square unit. Quite calm, okay. Now, you remember I ever convert, for example, meter per second to kilometers per hour, right? You remember we did that thing, or maybe kilogram per hour to gram per minute. But then this one got square, so not so simple. You notice that the square there, convert kilometer square to meter square, not so simple, okay, this one, in the exam, they will test you this. Ever explicitly, I think the last one test you this. It's not so simple. But you apply the same thing. You apply the same concept. The concept is the same, yeah. So let's go to this, okay? I will show you. Let me show you. Wait, let me. Um, I take away the clear patch. Okay. Let's do this, okay? Yeah. Now convert. Let me show you one that then you know what I'm talking about. Convert 4,000 centimeters square to meter square. Yeah. 4,000 centimeters square to meter square. Before you ever do any conversion, you must know the uh, what cm and meter. How do you represent cm? How do you represent meter? Right? So now, if I tell you, okay, you're going to convert, you forget about the two first, forget about the square. You look at the square, you don't know what to do. Forget about the two first. Take away the square. Yeah. So now you know that. Oh, okay. I am going to convert cm to meter. But it is easier for you if I convert meter to cm. Actually, it's easier. But when you go the other way around, small to big, quite difficult. Yeah. So how do you approach such a question? My suggestion to, to you is you approach the same thing, okay? So instead of saying 1 meter to 100 cm, you go the other way around because you need the cm to be here, right? You need the cm to be here. So you put cm here. So how do you do it? Okay. How you are saying, oh, okay. 1 meter give you 100 cm. Because I need to convert cm to meter, so I put cm here, meter here, okay? Same, but I know that 1 cm is 100 cm. One meter is 100 cm, yeah. But what I need to do is, you're looking for cm, right? So I'll make it 1 cm is equals to 1 over 100 meter, right? Yeah. Can you see or not? Yeah. Can you see what I just did? Yeah. Because straight away, if I tell, okay, 100 cm is how many meters? I don't know, how you convert? Yeah, but you could start with 1 month. Always, you start with 1, okay? You know that 1 meter is 100 cm, but 1 cm is 100, how many meter is actually 0 point something, So in order to know what is the 0 point something, you use this. 100 cm is 1 meter. 1 cm is 1 over 100. Well, you always divide by, when you find 1, then you divide by whatever it is, find 1, right? So 1 divided by 100 is, if you don't know how to move the decimal places, please use your calculator to press and get the 0.01, okay? 1, 2. So actually 2, 0. So 0.01 meter. If you're not sure, please don't use manual. Don't do manual calculation. Not sure, please use a calculator to press. 0.01 meter. Okay, 1 cm is 0.01 meter. So that is your conversion. So how does it relate to this? How does it relate to this? Let me show you. I am going to convert centimeter square to meter square. So now, so I look at this. 1 cm square, I need 2 cm, right? I mean, I need 1 cm times cm gives cm square, isn't it? So I need 2 cm. 1 cm times 1 cm divided 1 cm square, so I separate them again, equals to 1 cm times 1 cm. I separate them, yeah. The moment you separate them, very easy. You see, I separate them already, isn't it? But you have already have the answer here. 1 cm is 0.01. So you put 0.01 here, 0.01 here. This one become meter. So this one becomes 0.01 meter and 0.01 meter. So you separate them. So you have cm. So literally, what you are doing, you are actually changing it to meter. Changing it to meter. Separate them. So this one it becomes 0.01 times 0.01 meter. Now change already. Yeah. So equals to 0.01 meter times 0.01 meter. Meter will give you a meter square, isn't it? So all you need to do is what is 0.01 times 0.01? Very easy. When it comes to when it comes to one, the decimal place is very easy. You count how many decimal points. After the decimal point, 2, right? 1, 2, 3, 4, isn't it? So all you need to do is you need 4 decimal places. Because 4, 1, 2, 3, 4. So what I do is equals to 0.1234 meter square. Yeah. Okay. But I do not want 1, isn't it? So 1 cm square equals to 0.0001 meter square. But I don't want 1. I want 4,000. So you just have to take this and 4,000. That's your answer. Yeah. So it equals to, but I want 4,000. So equals to, so 4,000, 1, 2, 3, cm square equals to 0.0001 times 4,000. You don't know how to move the decimal places? Please use your calculator. 0.0001 times 4,000. What do you get? Someone? Actually, I look at here. If I know how to move, I will do this now. Oh, okay. 30. 1, 2, 3. 1, 2, 3. 0.1 times 4 is actually 0.4 meter square. Am I right? So answer is 0.4 meter square. But if you're not sure, don't try to move manually. Don't try. Use your calculator to calculate. Answer is 0.4 meter square. So just confirm 0.4, 0.4, answer. Okay. So very easy. Yeah. Separate them first. Make sure you separate the unit. cm, separate them. Okay. First one, you meter square, you come out on this type of question, they come out the square question. They come out square, I call it the square question. Is it okay, Mandy? Done? Okay, now you do the next one for me. I keep quiet. Do this for me, please. Next one. Do this for me. I let you do. 20 meter square to centimeter square. How you do? 20 meter square to centimeter square. So I put here 20 meter square, 20 meter square to centimeter square. Bring lower so you can see. And okay. Same method. How do you do? Use the same method. Tell someone meter to centimeter. So you can put meter first. Okay. Meter to centimeter easier. I don't need to reverse. No need. 1 meter, 100 centimeter. Easier. This one easy because big to small is easy. Small to big difficult. Okay. So 1 meter square is equals to 1 meter times 1 meter. I need to change centimeter, right? So I change it. 1 meter is 100, so I'll change it to 100. 1 meter is 100, so I have 100 here. 100. Okay. So it's 100 cm times 100 cm. I'll give you equals to 40. 1, 2, 3, 4 cm square. But I don't need one, right? I need 20. So it times 20. Times 20 equals, so 20 meters square equals to 20 times 10,000 times 10,000. 1, 2, 3 centimeter square. Okay. 20 times 10,000. So how many zero? 1, 2, you count 1, 2, 3, 4, 5. 5 0 plus a 2. Okay. 1, 2, 3, 4, 5 plus a 2. So 200,000 centimeter square. That's the answer. Confirm. Okay, confirm. Right? Big, big to small is easier. Small to big difficult. Cm square to meter, so small to big difficult. I will do a reverse. Yeah. But big to small, 1 meter I can convert already. 1 meter 100. Or maybe 1 kilometer to meter. 1 kilometer is 1,000 meter. Convert, yeah. But if it's meter square to if it's a meter square to kilometer square, then a bit difficult. You go do the reverse. 1 kilometer is 1,000 meter. Okay, so 1 meter is equal to 1 over 1,000. Yeah. Then you will do a reverse. Yeah. Okay. Just straight away you can't. 1 meter how many thousand? Because define first, you might not be able to get it. So do a reverse. Yeah. Some zero very easy. Just count zero. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Add 2. Answer going to be calculated. But if you're not sure, please use calculator. Okay, that will help you. Oh, good. Next one, Next one. Okay, let's see what is it. The next one. For now total surface area of the prism. Prism. Okay. Okay. Yeah. Now we have been talking about area of a flat surface, two-dimensional. What you're looking at is two-dimensional so far. Area of a parallelogram, area of a triangle, area of a flat surface, area of the paper, flat surface, two-dimensional. Now prism is three-dimensional. Okay, three-dimensional means that there must be a depth. There's a depth there. There must be a figure, an object. Say three figure. There's a depth. Now, what is a prism? How do you define a prism? Okay. Now, a prism, when you're talking about a prism must be an object, 3D object. The front and the back the same. Front and back must be the same, and the front and the back to make the object is joined by the length of something. The length is joined by the length. So what do I mean? You look at this, This is a prism. Why do I say this is a prism? Because the front is that you can see that the front 1, 2, 3, 4 the pentagon 1, 2, 3, 4, 5, and the back, they are the same, right? They're the same, isn't it? It's joined by the two of them is joined by the length here. The length just join them together. So this is a prism. Yeah. You understand? Okay. Is there any other prism I can show you? Uh, this is a prism. Why is it this is a prism? Because the top, the front of the top, and the bottom is the same. Joined by the length. Join them together. Yeah. You understand? Okay, so you must be able to identify the prism because in the end, area no problem. When it comes to volume, you must identify is this a prism, then you can calculate. Yeah. So the prism, the front and the back of the top and the bottom, they are the same, joined by the length. Is that okay? Yeah. I'm going to draw an object for you. You tell me whether it is a prism. Okay. I'm going to draw an object for you. So you have the uh, okay. Is this a prism? Do you consider this as a prism? Yes or no? Ask yourself. The front and the back, is it the same? But you look at this very carefully. Actually, the front and the back is the same, right? Or you can also take the front and the back the same, right? Or the top, the front and the bottom. So this is a prism, definitely. Yeah. Okay? This is definitely a prism. A rectangular box, a square box, they're all prism. Yeah. A prism. So it's not another one. You tell me whether this is a prism. Okay, another one, huh? Not so nice. Ah, Emma. Is this a prism? This one look, what does it look like? It looks like a cylinder, am I right? The container. The cylinder. Is this a prism? Is it a prism? Technically, it is a prism. Technically, yeah. Technically, it is a prism. But they don't use this, they don't call this a prism. Because why do I call this a prism in the first place? Because the top and the bottom the same, isn't it? Joined by the leg, right? Joined together, right? Technically, this is a prism, but in words, they don't call this a prism. Because when you define a prism, the surface must be flat. This surface is not flat. This surface is round. So they say, oh, this is not a prism. But the calculation, later on, when you do calculation for volume, it's the same as a prism. Because the top and the bottom is the same. So calculating the volume later on is the same. Yeah. So is this a prism? Technically, it's not, but calculation is the same. Yeah. Is that okay? Yeah. So this is technically, they say it's not a prism. So I'm going to draw another one for you. You tell me whether this is a prism. Next one, This is a step, right? This is a step, isn't it? I can walk on the step on top, right? Isn't it? This is a step. Is this a prism? This is a prism. Is this a prism? Why do you say this is a prism? The sides, like which side? The L, is it? The side, you're right. You're right. The sides are the same. You look at very carefully, this side and at the back, at the back, at the side, and this side is the same. You join by the same length. All the length are the same. Am I right? Is this a prism? Yes, this is a prism. Yeah. You need to know this is a prism because when you calculate the volume later on, very important. Yeah. Is this a prism? Yes, this is a prism. Yeah. Okay? And right now, I'll tell you. I think I have it on top of yeah. I was doing I was doing this with another class. Yeah. Is this a prism? Is this a prism? Is this a prism? How do you define a prism? The front and the back must be the same, joined by the line. Okay? Okay, so you look at this very carefully. Is this a prism? You tell yourself. First of all, this one, and at the back, this one, different, right? Okay, then you cannot say this is a prism. But if you tell me, oh, but here the same one, here and at the back, same, isn't it? Am I right? So you see, but it's not same. How can you say this is not a prism? But when I say that they are the same, it must join by the length, isn't it? The length here and the here different. There's a cut here. Can you see it now? So even though this is the same, but the length different. This and this, there's a cut here. Cannot. Yeah. Is this a prism? Answer is no. Yeah. Can you see? So when you calculate volume, if this is not a prism, you cannot use a method to calculate the volume later. You cannot use that method. So now you tell me, oh, this is not a prism. Because the front and the back is different and it doesn't join by the straight line. Yeah. This is not. Okay? So far so good? Right? Yes. Mandy, you look very worried. Okay, now come back to this again. Okay. Uh, let's continue. Okay, let's start. Yeah. Right, let's start. Is this a prism? This is a prism, This is a prism because the front and the back is the same. Joined by the length are all the same. The length, joined by the front, back, joined by the length, same. So this is a prism. But if I ask you to find the area of the prism, why you got a lot to find? I tell you why. You're gonna find this one. Am I right? But remember, I told you that if the front and the back is the same, you just have to find one, you times two. Am I right? Two, isn't it? Yeah. Then you need to find the bottom. Uh, then you need to find the top. The top, but apparently the top, this one is 10. This is 10. But I think this one also 10. They didn't say, so I think very likely it's a 10. This one also a 10. So this is a 10. This is a 10. Yeah. So I just have to find one. I times 2, isn't it? The front and the back, right? This one and this one, the same, isn't it? The front and the back, right? So I just find one times 2. The only difference is the base. The base I must find. Yeah, must find. Okay, so let's start. Let us start with the uh, triangle. Find, you're supposed to find the area, find the total surface area there. All the while, you've been doing two-dimensional, only one side, one flat surface. But when it comes to three-dimensional prism, you need to find a lot of area. 1, 2, 3, then in front 4, then at the bottom 5. Why you find 5? Then add them all together. Okay, let's do. Now, when you want to name them, well, very difficult. Okay, if I were you, I'll call you must give a name to the diagram. You know, when you calculate area, you tell them, oh, calculate this half base times height or length times breadth. You don't know what you're talking about when. You also don't know what. So you got to name your drawing. When you're doing calculation, name your diagram. Name them, okay? How do you want to name them? If it's like that, I can do a few naming convention for you. I show you, okay? I can actually do this. Oh, this side, Oh, this is A. This I change the red. This is A. This side is A. A means here lah. A is here. This side. Okay. This is B. B is here. Oh, this is C. C is here. Behind, right? Oh, this is D. D. But the problem is, okay, D is the base. D is the base. Then this one, how do I put E? E is here. This one, E. How do I put E? No space. Am I right? So a bit difficult, no? Yeah. So if you name like that, A, B, C, D, in the end I put E. This is E. E. I put E, for example. I also don't know where you put E. E can be at the bottom. E can be at the middle place. A bit difficult, right? Okay. So in such a circumstances, it is easier if you name all the vertex, A, B, C, the vertex, the joint. So instead of putting the plane as A, B, C, D, E, the joint has A, B, C, D, E. So what do I mean? You do this. So this is a bit difficult to see. So I'll put this. I put this. I'll do this. Oh, this is A. I sorry. This is A. Oops. A, B, C, D, E, F. Easier. Easier. So I'll start with triangle ADF. Where's ADF? You must know Then when it comes to calculating the marker will say, oh, triangle ADF. Oh, where's ADF? ADF. So you're looking at this triangle. Okay. So it's easier. In this case, it's, yeah. When? A B C D. Oh, this E. Sorry. A D E. Yeah. This F is that. Sorry, my mistake. A D E. Yeah. So it is easier to name your triangle on the vertex. Has a alphabet rather than the plane as A B C. So this is E. My mistake. This is E. Yeah. Okay. Okay. Let's do. Try area of triangle. Area of triangle. You cannot say area of triangle like that, no. You must tell them which triangle. In this case, ADE. Yeah. ADE equals to half base times height, right? Yeah. What is base? 6. What is height? 8. Or there, isn't it? Yeah. What is the base? 6. ADE. What is the base? 6. What is the height? 8. Yeah. So straightforward. So equals to half times 6 times 8 give you 4. 6 times 24, right? 2, 4, 6 times 4, 24 cm squared. Yeah. Area of triangle BCF. BCF. What is BCF equals to? Give me the answer. Also the same, right? Yeah. So I underline this one first. I need it later. Also 24 cm squared. Yeah. Okay. So now triangle, area of rectangle, area of rectangle, ABCD. Go and find where is ABCD for me, please. Can see ABCD lah. Because the moment I name them, you know which one I'm talking about. A, B, C, D. So literally this one, right? So what is the length? 15. What is the breadth? No. 6. No. I A, B, C, D. 15 and this is 10. I believe this is 10, but they didn't say. Because if they don't say, you can't find. You can't find this length if they don't tell you. Literally, they don't. But I believe they made a mistake. They forgot to tell you This and this is the same. Yeah. So this is 10. This is also 10. Yeah. Is that okay? Yeah. Or else you can't find it. Yeah. So equals to ABC equals to what's the length? 15. 15. Oh, don't use 15. But length times breadth first. Equals to length times breadth. Equals to 15 times 10 equals to 150 cm square. Underline this one. Underline this one. I need it to add them together. So what is area of rectangle? Of rectangle ABFE. ABFE equals to also same 150, right? This is the same, isn't it? 150 cm square. So the last one is area of rectangle. Underline because I need it later. Underline area of rectangle. CDEF. CDEF equals to length times breadth. Equals to what's the length? 15 times 6. 15 times 6. Answer please. 1 times 5 6 30 90, right? 90, yeah. 90 cm square. I underline because I need it. Total area. Total area equals to, I underline all, right? Add up all the underline. 24 plus 24 plus 150 plus 150 plus the last one 90. Final answer? 438, is it? 438 cm square. Just double check. 438. 1, 2. Okay? Yeah. Like I mentioned, actually the exam they must tell you that this one and this one is the same. So in order to make it the same, I'll tell you it's an isosceles triangle. Isosceles triangle, the left and right the same, right? The angles one must tell you. But apparently it didn't tell you. Or if you can't do, it won't tell. And you dare not take that it's 10. How can you take that? Remember I told you that you cannot assume that it is the same. Right? Cannot. They must tell you. So they made a mistake here, they didn't tell you. Yeah. Where? Angle? Which triangle? It's pi. Where? Where? Pi. Pi. Where? For the figure below shows a triangular prism. Yes. Yeah. But triangle that I didn't say it's an isosceles triangle. So how can you say that this is 10, this is that? I'm assuming they forgot to tell you. Which are right now, they forgot to tell you. Yeah. They must tell you, how you do. This is 10. How do you know this is 10? Yeah, but it's just 10, it's 11, right? Yeah. 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 So this one didn't say. They didn't tell you. They must tell you. Yeah. So if I put this way, in a triangle, let's say in the exam, I put this way. I put like that. So what does it mean? They are both equal. Now like that I can. Yeah. So they forgot to put the line here. They forgot. Yeah. They must put, or else you cannot calculate. Yeah. Okay. Any question? Any question? Did she join? How about she didn't join? Yeah. Somebody asked me, but never joined. See here. See here. Okay. Any question? No question? No? Good. Let's see the next one. Okay. The answer. Okay. Celinda. Okay, can I have a piece of paper? Anybody can give me a piece of paper? Give me a piece of paper. One piece.
Yeah.
No, need only one piece of it. Yeah.
I know, I usually
Oh, yeah, you do that.
Yeah.
Thank you. I'm going to demonstrate something. This is cylinder, okay? Right? I don't know, I'm sure this here, right? Show this to you. If I join the piece of paper together, okay, thank you for your paper. I paste them together. This is cylinder. You agree not? Is it a cylinder? All I need to do is to put a cover on top and put a cover below, right? Right? Okay. Cylinder? Cylinder? Now, if I ask you to find the surface of the cylinder, if I ask you to find the surface of the cylinder is curved, you know. How do you find the surface of the cylinder? You cannot use a measuring tape, right? Measure. How do you find the surface of the cylinder? How surface? If it's a flat surface, no problem. Then temperate. Am I right? Yeah. But this is curved. Now you see, watch very carefully, maybe also. If I open up the cylinder, I cut open the cylinder, I cut open it. Okay? I cut open the cylinder, it becomes what? It becomes a rectangle. You can find the area of the rectangle very easily. Length and breadth, right? I will find the area of the surface, isn't it? So for cylinder, all I need to do, if I ask you to find the surface area of the cylinder, all you need to do is find the circumference, 2 pi r. When you find the 2 pi r, it's actually like that, right? Isn't it? It's a line, right? 2 pi r. And I tell you the height of the cylinder. So what is the area of the surface of the cylinder? 2 pi r times the breadth, right? Or the height, isn't it? Or the height, right? You have the surface of the cylinder already. All right? Yeah. So in the exam, they ask you to find the surface of the cylinder. It is actually open up the rectangle. 2 pi r times the length or the breadth. Yeah, that one call it. All good. You may calculate this. Now you know why I take 2 pi r, right? And this is the surface of the cylinder. Okay. So if I have a cylinder, how to calculate the surface of the cylinder? 2 pi r times the length. That's the answer. Yes? Okay. Any questions? Now you know how I calculate, right? Okay. Yeah, I'm going to calculate this for you. Return to you. If you want, trade for you. Okay, thank you, Mr. William. Okay, now you know what. You see, they give you a. Can you see they give you a formula? Look very carefully. Can you see? They actually. I clear the screen first. Okay. Actually, can you take this away first? Okay. Can the surface of cylinder is 2 pi r h. Am I right? The surface of cylinder, right? Now this one and this one the same, right? Isn't it 2 pi r h? Why is it they add pi r square plus pi r square times 2? Why? Can somebody tell me? Why is it now? Surface of the cylinder is 2 pi r h. Sometimes you need to add pi r square times 2. Why do you need to add this? What? Very good. The top cover and the bottom cover. The top cover is pi r square, right? The bottom cover is pi r square, right? That's why pi r square times 2. Yeah. So for the area of the cylinder, you don't need to remember. Don't try to remember very hard. Area of the cylinder, like doing an exam, area of the cylinder is 2 pi r square plus pi 2 pi r. I better you go inside, you forget. Yeah. But if you know how to derive, you need to remember one. That's good. You can do it. Yeah. Don't need to remember by heart. Like tough. Yeah. You can derive it yourself. Yeah. No need to remember by. Okay? Yeah. So now you know why I add two 2 powers here? Because there's a cover up top and a cover below. The cover is round, isn't it? Round, right? Pi r square, yeah, times 2. Yeah. All right. Now with that, let's do okay. Let's do ready. Okay, let's do. Yeah. Let's see what they want. The figure on the right shows a cylinder of radius 5 cm. The radius 5 cm and the height is 24 cm. Find the total surface area. Now they say that the cylinder, they didn't say there's a cover, so there's no cover. They didn't say there's a cover, right? So don't go and add 2 pi r square. They don't go and add times 2 pi r square. There's no cover. Yeah. So cannot add the area on top. All you need to do is just use that 2 pi r circumference of the circle times the height, right? Which is the rectangle, isn't it? Yeah. So okay. Okay. Area of the surface. Area of the surface of cylinder equals to 2 pi r h. Yeah. Equals to what? 2 times pi, take 3.142, they already say, okay? 3.142 times r, 5 cm, times the height, 24 cm. That is your final answer. 2 times 3.142 times 5 times 24. Can I have the answer, please? 7 exactly, is it? 754.08. Okay. 754.08 cm squared. Is it correct? Oh, they add this one. Actually, they didn't say cannot. Okay, hold on. Come back to this again. Actually, what they did is, yeah, again, the figure on the right shows a cylinder of a radius 5 and total cylinder. They didn't say there's a cover, right? Yeah. Cylinder, if you don't tell me, I say there's no cover. Or maybe there's a cover but no bottom. Or maybe there's a cover bottom but no top. How in the world do I know? You must tell me. Yeah. Cannot assume cylinder has a cover. Okay, for no cover, the answer is 754.08. Yeah. But apparently, there's a cover. Cover, you can add the cover, so not fair lah. In the exam, they cannot do that. Okay? In the exam, they cannot do that. They cannot do like that and then ask you to guess. Cannot. They must tell you. Okay? But this is not exam, so a bit careless lah. Okay, they didn't tell you. But apparently, there are two covers. Okay, so this is the surface area, round, no cover. So if I need to add a cover, what do I do? Glass. Times square. How many cover there? Top bottom. Times two. Very good. You need two times two because top and bottom, right? Yeah. Need times two. Yeah. So okay, I have the surface area. Now I calculate the top and the bottom, okay, which is pi r square times 2. So area of top and bottom, area of, I underline first, because you need to add them together. Area of top and bottom equals to 2 pi r square. 2 times 3.142 times 5 square. Answer? 5 times 5, 25. 25 times 2 is 50. 50 times 3.142? 1572, is it? 72.1 exactly. Sorry, I can't do it. 157.1. Okay. 157.1, 157.1 cm square. Okay, total surface area. Total area equals to 754.08 plus 157.1. Give you uh, 9, 9, 11.1A. Oh, yeah. cm squared. Yeah, correct. They use this living figure. No, 3 decimal place. Okay, answer. Yeah. So just bring it down so you can see. All clear? How you calculate? When I say that, exam they cannot like that one. Not fair, okay? How do I know that I have a cover? You must tell me. Yeah, but then they must tell you. They cannot let you guess. Don't guess it. Must be clear in the exam. All good? Is it okay? Okay. I use the bar. So, anyone, any question? No, no battery. Must put it inside also. All good? No question, sure? No? Very clear. Area, I hate calculating area. When it comes to exam, calculate area, wow, very troublesome. After this area will be volume. Volume will be very easy. Volume, you know when you talk about area, area is about how big. Given area of the wall, area of the ceiling, area of the floor, add all the areas together. But when I talk about area of the volume, when I talk about the volume of the object, talk about how big, how much, easier to calculate. Especially when it's a present, very easy to calculate, okay? And you like it, you like it. Area, exam, we do area exam, do carefully, okay? One by one, add them all together. When you're doing it in the exam, do carefully. That's all I can say. But they are very easy, but you could do it very carefully. Yeah, bit by bit, or surface by surface, add them together. Okay. Move forward. Uh, okay. Maybe one more before you go for your break. All right. Let's see what they want. This one. Before you start, always understand what they want first. Okay. Now, the curved surface of the cylinder, you see now the curved surface has no top, no bottom. No top, no bottom, only the curved surface, right? Yeah. The curved surface of the area of the cylinder is 150 cm squared. Okay. They give you the height. You are supposed to find the radius. Radius. If I draw the cylinder out for you, let me draw a cylinder out for you, okay? You look like this. You look like this, cylinder. Okay, you're supposed to find the radius R. Okay, find radius R. Now, given that the area of the surface area is 1150 cm squared, given to you, yeah. You was giving you that the height is 7 cm from here to here. 7 cm. You're supposed to find the radius here. Use the formula. Use the formula. The formula is, if I want to find the surface area of the cylinder, just the surface area without the top and the bottom, it is only 2 pi r h. Yeah. So area of surface of cylinder equals to 2 pi r h. What's the surface area of cylinder? Somebody tell me. What is the surface area of cylinder? Is it given? Is it given? 150. So I write down. 150 is equals to 2 times pi times radius. You don't know, right? Times r times h. What's h? 7. 7. Okay. You're supposed to find r. I'm going to write it in the other side. 150 pi. Okay, I'm going to write here. Hold on, okay. 150 equals to 2 pi r h. H is 7, right? You're supposed to find r, isn't it? No, you're supposed to find r, right? Now, this is where you need to know your cross multiplication very well. The cross multiplication must be very good. There will be many instances in your maths, in your exam, you will need to use cross multiplication. Many. To find R, find H, find H, find area, cross multiplication. You must know it very well. You will need it. Okay. So this is what we have earlier. I have the area of the surface area of the cylinder. I have 150 equals to 2 pi. I don't have R. I got the height. You're supposed to find what is the radius. You can only find the radius if you know your cross multiplication very well. How do you do this? Now, you know that when it is like that without any fraction, it is actually upon 1 equals to upon 1, right? Same, right? If I want to find R, I must get rid of 2. Bring the 2 over. Bring the 2 over. Bring the pi over. Bring the 7 over. Remainder R. But how do I do it? I use the cross multiplication method. To throw away the 2 to the other side, I bring the 2. If you're on top here, you bring over, it becomes below. So that's why you say you must cross multiplication. 2 become below, cross. Pi, bring over. The moment you bring over the equal, you're on top here, right? On top of 1, isn't it? The moment you bring over, also below. 7 is on top, right? The moment you bring over, now you're on top. Bring over, also below, all below. So what do you have? You will have 150 over 2 times pi times 7. Over here, left r only, left r. Because you're 2 thrown below. R thrown below. 7 thrown below. So no more left, or only left R. Yeah. This is called a cross multiplication. You must know it very well. Yeah. So how do you do this? You don't try to use manual calculation. This type of calculation, you need a calculator to help you. Okay. Take, first of all, you take 2 times pi times 7, find out the answer, then take 150 divided by this. Yeah. Maybe you give me what is 2 times pi times 7 first. 150 divided by 2 times pi times 7, somebody please. 7 times 2, 40, 40 times pi. Somebody give me the answer, please. Maybe okay. Somebody waiting for me at the where? Nobody there, right? This person, there's one opposite behind one. Sorry, Chris can join, will join the person. Okay, sorry, back to this again. What is 2 times pi times 7? 43.98, is it? Equals to r over 1. So what is 150 divided by 43.98? R equals to 1, so 150, 50 divided by 43.98 will give me 3.416410, right? 3.410. You notice I add another number there, 4 decimal place. Because I'm going to make it to 3 decimal place, right? So you must look at the 4. So it become 3.411, 3 decimal places, okay, equals to R over 1, cm. Answer lah, 3.411 lah. Is it 3.41? Just double check. 3, correct. They use significant figure, no good, okay? You should be using decimal places. Okay, we have done with area. I'll show you how you calculate area. It's just that when you're calculating area, you just need to be very careful. The surface area of the, whether it is a cylinder or it is a prism, a lot to calculate. But when it comes to volume, easier. Remember I told you area is about the surface area. Volume is how much space you have in the object, how much space. If I ask you to calculate the volume of in the room here, so you're calculating the space, okay? The top, bottom, the air surrounding, everything, the oxygen, the air literally, how much volume of air. So for area, when it comes to area is always a length times breadth, half base times height. Area is always meter square. Volume, when it comes to volume has a depth. There's a depth, so it's always about length times breadth times height. Volume is always meter cube. 3 is always a 3. Volume is always 3, okay? So whether you're calculating the volume of a prism, calculating the volume of a cylinder, volume is always meter, is always cube. There's a cube, yeah. Just like if I ask you to calculate the volume of a box, okay? If I ask you to find, what is the volume, what is the area of the box? Area of the surface area of the box, you just calculate length and breadth. Length and breadth, that's why you have meter square, okay? Meter square, all add up together, yeah. But when you need to calculate the volume, you need to calculate the length, the breadth. You must also consider the depth, yeah. They call the length, the breadth, and the height, the depth. You always consider the depth. So you need 3 things. 1, 2, 3. That's why you 1, 2, 3. That's why you have 1, 2, 3. That is why you have meter cube. Yeah. Volume is always meter cube. Yeah. Okay. So there's a depth. You calculate the object. There must be a depth. So look at this. If I ask you to calculate the volume of the cuboid, the square, like the square box, it's actually length and breadth from the height, right? Length, the breadth, the height. So it's as good as saying length times length times length 3, no? Okay, length 3. It's not 3 length. It's not 3 length, okay? It is not like, okay, length and breadth, the height. It's not 3 length, okay? It's not 3 length. It is not 3 times L. It is L times L times L. That's why you have L cube equals to L cube. Yeah, 3. Calculate the area of the rectangular box. Length times the breadth times the height. Length times breadth the height is as good as saying length times length times length, isn't it? It's just that length times length times length, you're looking at box. But when you're talking about triangular box, you cannot say length times because they're all different. That's why you use the word length times breadth times the height. Yeah. If it's a box, it'll be length times the breadth times the height. Length times length times length. Okay, same thing. But when it is a prism, look very carefully. Prism is different. The moment you identify it as a prism, all you need to do is you're going to tell yourself where is the front, where is the back. You must tell yourself where's the front, where's the back, because that's very important. The moment you have the front and the back, the prism in this case is a triangular. The triangular, right? The front and the back of the triangular is the same. So that is the front and the back. But I just take one area only. I just take the area of the triangle. The back is the same, right? I take the area of the triangle, I times the length that join the back. That is the volume. That's it, done. I don't even cover this surface area. I just find one area, that's the length, that is the volume. Yeah. Okay. So if I ask you to find the volume of this thing, find the volume of the triangular prism. All I need to do is half base times height, which is a triangle, right? Times the length. Half base times the height area of the triangle times the length. I still have meter cube because I need, this is meter square area. This is meter times meter still give you meters cube. Yeah, even the area also give you meters cube. The volume also give you meters cube. Okay. Yes. So if I draw a ladder for you, okay, come back to this ladder thing. Just I ask you a question, right? Is this a prism? You say yes, isn't it? So if I ask you to find the volume of this prism, how do you find? Use what you learn. If I ask you to find the volume of this prism, identify where's the front, where's the back. Make sure both are the same. The L, right? Isn't it? So you just take one. Remember, I told you take one only, right? Don't take two. Take one only. All you need to do is to find the area of this. I find the area of this. How to find the area of this? Very simple. I divide into two. First of all, I find this area, rectangle. Then I find this area, another rectangle, add them together. I times the length. I have the volume already, isn't it? I don't care about the step. I don't need to care, yeah. I just need to find the cross-sectional area times the length. That is the volume. You don't have to worry about the shape. I'm going to give you another one. You tell me how to find the volume. Yeah. If I give you a shape, I give you this shape. Tell me how you find the volume. What is this? Cylinder. Very good. Where is the same? Which one is where is the same? Which part is the same? Which part is the same? Top bottom, right? Top bottom, is it? If I want to find the volume of this cylinder, all I need to find is to find the area, the top or the bottom, am I right? So are they the same? How do you find the top or the bottom? What is the formula? It's a circle, isn't it? What is the formula for the area of the circle? Pi r squared. How to find the volume? Times what? Times what? Pi r squared times height. The volume already. Yeah, correct. They are the same, yeah. Even though you don't call this a prism, the cylinder behaves like a prism, okay? Because it is still the same, yeah. But just that it's a curved surface only. But behave is still the same, it's like a prism. So same thing. Now you know already. The area of a volume, the volume of an object is the cross section. The definition is the cross sectional area times the height. That is a volume. So let's do. Let's do okay. I clear this. Ask yourself first, is this a prism before you do? Is it a prism? Is this a prism? Why do you say a prism? The father saying, what shape is that? Trapezium. Very good. Is a trapezium. The top is a trapezium, the bottom is a trapezium, and they are identical. All you need to do is to find the area of the trapezium, right? Times the, what's the height? Very good. That's answer. That's the volume. Yeah. Remember area only one, find one cross section area only one. Don't go and times two. Take one cross section area times the height. Yeah. So that's good. Now, by the way, the trapezium, look at the one on top, okay? What is the height of the trapezium? It's 8, but I know that it is, when you look at angle, actually it's not 8, right? It's slanting, isn't it? But because it cannot drop, right? So they drop all the, okay, this, you're looking at it, and you're looking at the top, down, yeah. So exactly, yeah, okay? When it is slanting, it's not 8, I know. But they're trying to show you in a Z, you're looking at exactly down, yeah. Okay, let's do this. So the first thing I need to do is to find the area of the trapezium. So area of trapezium equals to half. Always write down the formula first. A plus B times the height equals to half. What is A? What's A? A? 20. This one, right? What is B? Very good. Below the same, isn't it? 45 here. Here is also 45. 45. What is the height? Don't get confused with this, huh? What's the height of trapezium? What's the height of trapezium? 8. Very good. Half times 20 plus 45 is 65 times 8. A calculator, 4 times 65. 5 times 4, 20. 6 times 4, 24. 26, right? Is it correct? 260? Somebody check, please. 260 cm what? Square, yes. Now this is the cross-section area, isn't it? If you want to find the volume, what do? So volume equals to 260 times the times the what? Huh? Times the length. Where's the length? Very good, 30. The height, the 30, yeah. 6 times 3, 18. 2 times 3, 6, 700 cm cube. Answer. Okay. But it must be a cube. So volume is really easy. So when it comes to exam, please do the question that I'm supposed to ask you to find volume. I can tell you most of the time they will give you a prism. They will give you a prism. Because if it's not a prism, to find volume not easier. If I give you, okay, I give you another one. And you, yeah, you're calculating. You write down first, write down first. I give you another shape. And then tell me how you calculate. Finish it, yeah. Okay. Finish already, is it? At the back. So if I give you I give you another one. If I give you this, for example, this one you look familiar to you, isn't it? It's just like a stick that you rub here, right? In the olden days, they use it to shout, and then the voice will project. The only difference is this one, is it a prism? Why no? Huh? The circle different, right? Yeah. So if I ask you to find the prism of this, find the volume, you cannot find. You don't know the formula, you can't find. Yeah. So they will not give you such thing. How to find? Cannot find. Yeah. You need the formula. So set one they will teach yet. So very likely they will give you an object, very likely to be a prism, then you find. Yeah. So it's cannot. The top circle and the bottom circle, they are circle. The signs are different. The sizes are different. It will not give you this. Not fine. Okay, so 7800 cm cube. Okay. Let's clear the page so that you can do it on your own. Okay. Now this one. Now they tell you already very clear a triangular prism. Triangular. So triangular prism, you know, right? This is triangle in front, triangle in the back, joined by the length. Isn't it? Sounds familiar. A triangle prism of a volume, they give you the volume already, 210 cm cube. The length is the one that joined from the front to the back. That's the length. The length is 14 cm. So the one that joined from the front to the back, the cross-section area. What the base of the triangle is 10. You're supposed to calculate the height of the triangle. Okay, height of the triangle. So if I draw, it looks like this. Which you look familiar to you already, all of you, huh? It look like that. Join to the back. Okay, behind, What is the volume? The volume already given to you, Total volume 210 cm cube. Base of the triangle is 10. They give you 10. You're supposed to find the height of the triangle. That means find this one, this one, All you need to do is to put in the volume of the triangular prism. So I put it down here, easier to see for you, okay? Of you, you can write it on your paper there. Okay, volume of triangular prism. In this case, is half base times height times the length. Am I right? This is the area of the triangle, isn't it? Half base times height, right? This is the length that join from the front to the back. Okay. Now they give you this. They give you this one, right? They give you the volume already. The volume given to you is 210 cm cube. They give you this. I put now 210 is equals to half. Did they give you the base? Did they give you the base? Yes, the base is 10. The base of the triangle, they give you 10 already. Yeah. So I put 10. What is the height of the triangle? You are supposed to find. So don't know. But they give you the length. The length is 14. 14, 14 here, okay? So this is times the length. Length is 14. The height don't know, wait. Times the height times 14. You don't know height, right? So in order to solve it, what must you do? What must you apply? What must you apply? I always say, yeah, every class I go to, I always like, you must know your cross multiplication. You must know, because chapter 7, chapter 8, chapter 9, they are all cross multiplication. You must know, yeah. Even though the paper they didn't teach here, but you must know that's how it works. So what do? You want age, right? But height event. What must you get rid of? You look at this statement here. You want height event. What must you get rid of? You want age only. So you must get rid of what? 2, throw away. 10, throw away. 14, throw away. Remainder. When I say throw away, that means bring over to that. Don't really throw. Bring over to the other side. Equal. Okay. So let us do. Let us do. 210 means what? 210 divided by 1, right? Over 1, isn't it? 210 over 1 equals to half. 10 means what? 10 over 1, right? 10 over 1 is a base. 10 over 1. H means what? Over 1. 14 means what? 14 over 1. It means over 1, yeah. When I do this, I hope you can see that when you bring over 2, over here is below. Bring over there become on top. It is always, that's why I say cross multiply. Cross means opposite. Yeah. 10 is on top. I bring over the equal 10 become below, right? H. Do you need to move H or not? No need. Stay there, right? 14, you need to move. 14 will bring over become where? Top bottom. Top bottom. Bottom, because here on top, bring over become bottom, right? Okay. So you do a cross multiply. You do a cross multiply, 2 bring up, 10 bring down, 14 bring down, remainder H, yeah. Okay, let's do. So you have 210 times 2 because crossover, right? That's all already, isn't it? Equals to 10 bring down times 10, 14 bring down times 14, remainder H over 1. All you need to do is use a calculator. 210 times 2 is, if you know your calculator very well, you know how to use the memory, you know press memory, right? If you know how to use a calculator very well to press memory, straight away you can find the answer. If you do not know how to use your memory in a calculator, then do part by part. Do the top first, then you do the bottom first, then you put them together. So in this case, let's say for example, I'm not sure about how to use the memory. I'll take 210 times 2, you give me 420. 420 divide by 140, 10 times 14, 140, yeah. Cancel, equals to H over 1. I'm sure you can find the answer. 42 divided by 14. Answer, please. 3, Exactly, is it? Oh, I see. That's not bad. H over 1, 3 cm. So H over 1, 3 cm. That's the answer? Yeah. It's the same as 3 cm equals to H. Same. Do you know your cross multiplication? Do you know your cross multiplication? All of you. You very good. You must be very good. Very, very good. Yeah. You want to tell me how to find? I'm going to give you a statement. You tell me how to find. Okay. All finished already? Let me copy first before I continue. Finish it. Okay. Okay, I'm giving you already. Yeah. Now, okay. Look at this statement. How many unknown are there? Unknown, don't know one. How many unknown are there? Only one. What is that? Very good. In the statement here, If there is one unknown, you can find the answer. If you got two unknown, it's difficult. There's an R here, there's an S there again, you cannot find any answer. Okay? But if there's an R here, I can find answer. Yeah, that's why there's only one. Yeah. Now I want you to find R from you. Solve R from you. Need a lot of cross multiplication. Need a lot of cross multiplication. Okay? Solve R from you. How do you do this? Now you're going to apply all that you know. BODMAS. Use BODMAS to help you. Yeah. Use the cross multiplication to help you. Yeah. Solve R. BODMAS, right? You need the BODMAS to help you, isn't it? So what is the first thing you do? You look at this. What is the first thing you need to do? If you apply BODMAS, you know that you got to do this first. Am I right? Okay? Number one. Number two, do this. Followed by this and this, right? Because they're both time, isn't it? Okay. This one later. So 45, 42 divided by 5, you can't do anything, right? So I'll probably do it like that, you know. I will not even calculate because the more I calculate, you give me a decimal point. Yeah. So I'll leave it alone first. I will take 42 divided by 5. I just leave it. Yeah. 42 divided by 5, I leave it. Plus, what is R times 2? 2R. Oh, you can calculate. What is 3 times 2 over 5? 6 over 5, right? 6 over 5. So far, so good? You want R, isn't it? If you want R, what do you do first? Tell me. You want R, what do you do? You must put R alone. But before you put R alone like that, okay, the 2 is with the R. But what is the first thing you need to get rid of? Huh? The 2. Not yet. Not yet. You cannot get rid of the 2 because the plus is there. You cannot throw away the 2 because the plus is there. So you got to get rid of which one first? 5. Not just 5. 40. Not just 42. The whole thing. 42 over 5. Get rid of 42 over 5. Bring it over there. When you bring over there, become what?
6 right? Right now.
I knew it. Cannot. You cannot cross multiply. You know why? You 6 times 5, you take 42 times 5, right? Cannot. Why? Because the plus is there. You got to bring the whole thing there first. This thing is a what? 42 over 5 is a plus. There's a plus here. Actually, there is a plus here. There's a plus here. Am I right? So you need to bring this over. It become what? It become 2R equals to 6 over 5. This one become what? This is a plus 45. You bring over become minus 42 over 5. Yes. Yes. You cannot do cross multiply yet because the plus is there and the minus is there. Cannot. Yeah. So now this method, how do you solve the problem? Tell me. What have you learned? To solve this, you learn LCM, right? You learn LCM already, isn't it? But now you don't need LCM. You know why? Because the denominator is the same. So the LCM is 5. LCM is 5, yeah. 6 minus 42, what do you get? Huh? 6 minus 42, what do you get? What do you get? Minus what? 36. Minus 36, very good. Minus 36 because 42 is, the number is bigger, right? So you must follow a bigger number behind. So equals to 2R. 2R equals to minus 36 over 5. Now R is alone, Get rid of what? What do you want to get rid of? 2. How do you get rid of 2? Can you do cross multiply now? You can. It's alone already. The moment it is alone, you can do cross multiply. Alone already. Get rid of 2. 2, this is actually 2 upon 1. The moment you bring over 2, become what? 2 on top, become over here, become 2 below. Opposite, always opposite, yeah. So equals to, this is the same as 2r over 1 is the same, minus 36 over 5. Cross multiply, bring the 2 over, so become below. So r over 1 equals to minus 36, 5 times 2. Yeah, 2 become below, okay. R over 1 equals to minus 36 over 5 times 2 equals to R over 1 equals to minus 36 upon 10. Change to decimal point, R equals to minus 3.6. Answer, yeah. That's how you do cross multiply, yeah. Apply what you learn, yeah. What comes first? Then after that, throw all the other number away. Leave the alphabet alone. The moment the alphabet is alone, you can cross multiply already. Yeah. Right? Your cross multiply must be very strong. I repeat. The moment your cross multiply is very strong, you can do anything. Anything. Yeah. Anything. I repeat. Anything. Ready? Another one? Ready? Okay, another one. Okay, give me another one. Finish? Ready? Oh, good, behind. You have copy first. Yeah, you have copy first. Yeah. Okay, okay, okay. Copy already, is it? Okay, I'm going to give you another one. I'll bring it. Okay. I'll give one. Where? Where? I'm thinking of how. Okay. How many unknown are there? One. Why one? Because they're the same. Yeah. So when they're the same, one. Unless the RS, AB, then count how many. So even though there are R3, 2 R here, R there, they are still R considered one unknown. Start. How you do this? Find R. How you do it? 3, 2 times R3, 2 times R3, okay? Okay, I think not so good. Or you can change, change this to times. My mistake. I change this to times, okay? Yeah. and I change this to plus. Don't know whether can or not. Yeah. Minus 1/3. Cannot. Too difficult. Okay, that is easier. Sorry, sorry. So there are all times here. If I put a plus there, quite difficult, so cannot. Times. You still have the R3 there? In the R, right? Yeah. Okay, look at the question again. Just do some changes, okay? Make it lower so you can see. 46 times 2 times 2r cubed times 1/3 equals to r times half. Yeah. How do you do this? Okay. You do this? You can do it. Come on, you can do it. I'm sure you can do it. No plus, no minus is easier, okay? It's easier. No plus, no minus, easier. With the plus and the minus, a bit more difficult. Yeah. So if you look at this, okay, you must put the R together, right? You tell yourself, your R must be on one side, the rest on the other side. Yeah. So if I do, they are all, since they are all times, I will just times them together. Okay, so I will do this. 46 times 2r3. I will take 46 times 2 first. I will get it 92. 92r3. 6 times 2, 12, 9. Okay. Times 1/3 equals to r times half. So far, so good? Yeah. So far, so good, right? So now I'll bring them together. I'll take, okay, 92 times R3 is 1/3, isn't it? So I'll take 96 R3 divide by 3, same, right? Equals to R divide by 2. Am I right? So far, so good? All good, all of you? Do you know how to get this? You tell yourself, you are going to bring R3 is here. R is here. You're going to bring this R over here. Because there's more here. Okay? I can bring it here, but bring it will become below. So you cancel become below. Still can solve, but you will go a bit more. Easier to bring this R over here. Okay? So I'll bring 96 across. I'll bring 3 across. 96, when I bring across, it will be below, right? Oh, sorry, 92. Actually, sorry, my mistake. My mistake, 92, cancel, 92. If I bring 92 across, it will be 92 below, right? If I bring 3 across, 3 will be on top. cross multiply, isn't it? So you always remember cross multiply. It must be opposite here. So I'll throw away the 3. I throw away the 3. I'll throw away the 3. I throw away the 92. But R, there's an R here. You got to bring over here. Yeah. Bring all the R together. So I will have R3. This one bring over become R equals to 3 over 96 times 2. Do you agree? Look carefully. Do you agree? I did this alone. Maybe you calculate first also can. Yeah. You can calculate the whole thing. You can calculate 3 divided by 96 divided by 2. You can, okay? But this one, the tricky side is actually here, you know. I got 1 R here. I got 3 R on top, am I right? I cancel, this one remainder. How many R? R squared, R2. R squared, yeah. R2. So you can cancel. R also can cancel one, no? As long as they are the same. So I'll cancel 1 R. Cancel become 2 because you cancel 1 R below. Why R? Actually, this is R times R times R. You cancel R become 2 R squared. It's the same, right? Okay. So now I have R squared is equals to, can you give me the answer for this first? 3 divided by 12. 6 times 9 to 18, 192. Am I right? Can you give me 3 divided by 192, please? R square is equal to, give me a decimal place. I think it's going to be, 92. 6, I always say 96. Don't know why. Something that comes to mind. You know why 96? I always think that because 96 used to be my house number. So 96. But if I do like that in the exam, I finish already. Lose marks. 92. So if it's 92, it is not 192. It is 2 times 2, 4, 9 times 2, 18, 184. Somebody give me the answer, please. 3 divided by 184. 0 point. 0 point. 0.01163. Maybe a 0. 0 then no need because I want 3 decimal place, right? A 0 in the end, you cannot count for. But I do not want R squared. 1 R. I want R. I don't want R squared. So how do you solve this? Square, right? I don't want square. I want R. So you must get rid of the square, right? Isn't it? You square, you can bring over the square, bring over. Square also must bring over. Over here, you bring over, top become bottom. Bottom become top. Plus become minus. Minus become plus. Always opposite, right? Square, I bring over become. What is the opposite of square? Okay? No? Square. What is the opposite of square? Square root. Very good. Yes. The opposite of square is square root. It's opposite. And you bring over the equal, everything is opposite. Top become bottom, bottom become top. Plus become minus, minus become plus. Square become square root. So when I bring over the 2 over there, it becomes like that. It becomes like that. It becomes R. It becomes, I write for you, R equals to square root 0.0163. Or you can't calculate manually like that, right? You take a calculator, bring 0.0163 and you press square root. What's the answer? Yeah. Very small, is it? Oh. 0.127. Exactly. 0.127. Give me one more. 6. Okay. 0.1276 equals to 0.1276. The moment I ask one more, because I say you need 3 decimal places, right? So that when it is a 6, so bring over, it becomes 7, become 8, isn't it? So R equals to 0.128 bracket 3 decimal places. Yeah, that's the answer.